Hi everyone, so I decided to put together a couple of review videos just from last year, just because I've noticed that some people are having trouble with this concept of graphing and calculating slope and distance from a graph, from a VT graph. So basically I've set out a bunch of questions that I want you guys to work on underneath and do your work on your OneNote. The question one will always be the same, record a voice note describing the graphs here. So the first one is a straight line graph. So to describe this one properly, we would say something along the lines of the object starts, or the graph shows that the object starts from rest and accelerates uniformly, and we can tell it's uniformly because that line is a straight line graph for 10 seconds until it reaches a speed of 60 meters per second. So again, I'm just watching my language and making sure I'm using the word speed, and I'm making sure that I include a time interval. Now obviously for some of the other ones, they'll be a little bit more tricky because you'll have 2 lines and even 3 lines. Let me fix that one there later on. You'll have 3 lines on the last one, okay? What I want to do now is calculate the acceleration at the interval shown. Well, there's only one interval shown here. The acceleration of the object, whatever it is going to be the slope of the line. And we've discussed this in class. It's the rise over the run, and this is the way we should be looking at it. So we know that the line has risen by plus 60 meters per second over a time interval of 10 seconds. Okay, so in this case, it was the full time interval that it was accelerating for. Okay, that's not necessarily always going to be the case. And in the one underneath, this one, it's only going to accelerate for that first time interval. Okay, so the acceleration is a positive 6 meters per second squared. Okay, positive 6 meters per second squared. Now here's the thing that I didn't run through with you in class, and I'm just conscious that I have a feeling that people can't remember how to do it, but we don't really have time for me to go back on it all the time. So to calculate the total distance traveled, the total distance traveled, if you notice here, or even if you think about your formula, speed equals distance over time, then now, okay, this you wouldn't use in this case, but if you just think about it for a second, this gives us distance is equal to speed multiplied by time. Okay. Now, if you look at what's on your vertical axis, you've got speed, and on your horizontal axis, you've got time. Okay. So you could imagine that speed multiplied by time, well, according to this formula, gives us a distance or displacement. Okay. So this is where the idea comes from, that if you take the area underneath the line graph, or I like to say it like this, the area between the line graph and the time axis will give you the distance traveled or the displacement traveled. Okay, so that's what we'll do. We're going to find the area. The area, now please try not to get mixed up. The area has a unit of meters per second, meters squared or centimeters squared. I don't mean the area of, this isn't a measure of area, to be honest, okay? This is a measure of distance or displacement. But we calculate it by getting the area. And this is something that we would look at later on, much later on towards year 12 and year 13 level, when we start to look at calculus. Okay, so that's a long way away for you guys yet. So distance is going to be the area of the triangle. So this is a triangle, and because it's a triangle, you would take the area of a triangle is the base, half the base times the height, and then you divide it by 2. Now you can tell why you divide it by 2, because if you look at this one here, let me just shade it here for a sec. This is a triangle. If I was just to take the base times the height, that would give me the area underneath this entire line here. Okay, but that's not what I'm after. I need exactly half of that. So to get half of it, you just literally get half of it. You divide it by 2. So the distance traveled will be the base, which is 10 seconds. Let me put it the other way around. I'm going to go with speed first. It doesn't make a difference. The speed is 60 meters per second times 10 seconds. And you divide the whole thing by 2. And that gives me, well, on top, I've got 60 times 10, which is 600, divided by 2. Now watch what happens with the units. I have meters per second here, and I've got seconds above the line here, so this one will cancel out with this one. We're left with a unit of meters. That gives us overall 300 meters. That's my distance. Okay, so I do apologize, the video is a little bit longer than I expected, but hopefully that sums the whole thing up. So point number 1, from a speed time graph, if you take the gradient or the slope or the rise over the run, this will give us the acceleration. Okay. From that same speed time graph, if you take the area between the line graph and the time axis, then that will give you the distance traveled. Okay, or technically the displacement. So hopefully that helps. I'd like you to go down and try the questions that are below. Do split them into regular shapes. Don't try to work it out the way they are. I wouldn't even be able to do that myself. Okay, split them into for the displacement, split it into a triangle and a rectangle. Work out the areas separately. This one I'll change so that you'll probably have maybe 2 triangles or something in this one. Okay. Okay. Best of luck with that, and don't forget, fill it out on your OneNote.